Hello, programmers. I hope all of you are doing well and are staying healthy and safe in these crazy, crazy times. Anyway, the way we're going to do this class, I imagine, I might, seeing how Wednesday goes, I might adjust over spring break, and we may do it slightly different coming back from spring break, but the way I think this class will work the best at this point is for me to do an online lesson. I probably record about 45 minutes to an hour of an online lesson, which tends to be, when I'm just going through it without people's questions and problems, that tends to be a full class's worth of work. So yeah, I'm going to record a 45-minute to an hour lesson and upload that for you guys to work on outside of class, and then we meet during the class time to go over whatever issues you've had with that process. This way you can pause and rewind, and more importantly, you won't be having to juggle trying to see my screen on your computer at the same time as you trying to work on your computer. I imagine that would be very difficult for those of you who don't have like an external monitor. Now, if all of you have an external monitor or a TV that you can attach your computer to with a HDMI cable or something like that, then maybe we could do real-time lessons. Let's talk about it on Wednesday. But for now, we're going to today we're going to fix this little issue that sets the wheels spinning right when you first open the patch. That's an easy fix. And then we're going to go ahead and start adding in the logic to do the payout system. We'll start with a simple payout system that go away. A simple payout system that simply has a few different conditions. I said go away. And then don't ask again. Leave me alone. Then we'll have a more complex one that we'll work on from there. But we'll see how long this takes me. All right, cool. So first things first, we want to get rid of this spinning. You should have had 3 wheels now that spin and stop in the correct places. Right now there's this little bug where they're spinning when you first open the program, but as soon as you ooh, that's a big bug. As soon as you click the thing, they should start behaving normally and stop one at a time and stop. Great. So that's working for the most part. Now let's take a look at how we can fix those spinning wheels. There's a couple different ways you could do it. Go inside your spinner 1, and remember, just always look up here if you don't know where I am. See, that shows you where I am. It's project 1, spinner 1. So one thing we could do, so what's happening is, the reason why they're spinning when you first open it is because this random speed still has a value in it from the last time the program was run. So there's a couple things you could do. You could, down here, where in our ChopExecute 2, which stops the wheel when it gets to when it does looks at LFO 1 channel 1 and does a modulus of 1, and when that gets down below 0.1, it sets that sustain level on trigger 1 to 0, which stops the wheel. We could, at that same point where the wheel stops, go ahead and set the constant there to random speed to 0. Random speed, I think it's called par.value 0. And that would, as soon as the wheel stops, it would set that random speed to 0. So the next time that we ran it, it would be 0. But you don't necessarily have to do that. There's a workaround, an even simpler workaround, and that's simply just changing the order of this override. Because on load, this override will send the value of its top. If nothing's changing between the two, it will send the value from its first input and out. So right now, when you load it, if nothing is changing, and nothing should because nothing has happened yet, right now these are patched with this going in first. So this is its first, so it sends this 0.9 or whatever your random speed value is out that input. So if we simply disconnect this, and this is going to cause the LFO to break, disconnect it, reconnect it so that it's the second input, then that will always, when you load it, it'll always send this math 0 out as its primary input, and then it will always start with a 0 so the wheel won't spin. But now we just need to fix this LFO, and the reason why the LFO stopped working, if I open the parameter window, is that it's looking for, on this lag, a thing called chan1, and that was because that's what the channel coming out of random speed was called. See, this is called chan1. This channel is called done, and so now this override says done, the lag says done, and the LFO is looking for the word done, and it can't find it, so it doesn't know what's going on. So we could either change this to done, and that would work. But an even better way to keep errors from like this happening again is to simply specify the channel by index number. So if I say this is just channel 0, then it doesn't matter whether it's called done or whether it's called chan1. The LFO will always pull the first channel from this lag object regardless of its name. And so that's what I wanted to do from there. Now, why is this mad? I must have made a programming error. Float argument must be a string or a number, not a none type. Random speed. Oh, because now this says channel 1 on LFO, and now it's renamed itself. No, that's not right. That's not right. If op LFO1 chan1, let's just change that to 0, see if that fixes it. And we don't need this anymore. Let's just get this. Maybe it was this that was causing the problem. All right. So let's go ahead and push the button. And did it break? Nope, it's working. Okay, so let's go ahead and add those changes to the others. So if what I just did, because I showed you a few things, is confusing, I'm about to do the same things in spinner 2 and spinner 3. So if spinner 1 was confusing, take a look at what I do in spinner 2 and just do that. So what we need to do, all we need to do is delete random speed, the connection between random speed and override. Right? That breaks the LFO. Then we reconnect it to override, making it the second input. Then here on LFO, change its reference here on frequency from chan1 to simply get rid of the single quotes and just put a 0, no quotes. Then that will point to the first channel of lag no matter what its name is. That should be all you need to do. You shouldn't need to add any code to this whatsoever. This is the code that should be in each of these spinners. Okay? So that's working now. Spinner 3. random speed, delete this connection, reconnect it to make it the second input, redefine this frequencies reference here from chan 1 to simply channel index number 0, and that should do it. Now, if we save this, close it, and okay, whatever, and reopen it. So now you can see that when I load, the wheels aren't spinning. Okay, cool. There was another thing that I changed, I believe. So I think, let's close that. I think I adjusted this formula in the wheel 1, 2, and 3. Here, let me line these up so that it makes it a little bit more obvious what we're doing. So do I have two of these open? Which one's which? There. All right. Let's move this stuff out of the way. No. Go. Just move. There we go. Okay, so wheel 1, 2, and 3, they have this, I believe we had something like times negative 36 plus 72 or something, which made it, and I changed that to plus 35. So this should be so it's op wheel post 1 channel 0 times negative 36 plus 55. And the reason why I did that is because it changes the offset rotation just a little bit, so that this 0 or whatever the number is that you're currently on is kind of in the middle of this slot, I believe. And because the slot is kind of, this slot machine is kind of tilted backwards, the way we had it before had the numbers kind of at the very bottom, and they didn't appear to be in the middle. And so changing that offset just a little bit made them right in the middle of the slot machine. So if you want, on wheel 1, wheel 2, and wheel 3, just change these numbers to times negative 36 plus 55. It doesn't actually matter. It's a visual thing. It won't really change it won't change the logic that we're about to add. Okay, so now we want to actually add this logic. So we are going to go ahead and push the button so that you get values coming through. Wow, that didn't work. Wonder why. What happened there? Why did I have to hit that 3 times? It's working now. I'll try and see if I can figure out what that bug is. I'll let you know. All right. So we have 3 values: 6.06, 8.06, 2.05. So we don't want to actually try to evaluate 6.06, 8.06, and 2.05. We want to actually evaluate 6, 8, and 2. And the reason why there's that very small amount is because this is, the thing is calculated on a per frame rate, but the math moves faster than that. So when the frame updates and it runs that ChopExec in the spinners here, ChopExec 2, that's looking for this modulus of 1. It's always slightly gone past rolled. This modulus gives you a floating point value that goes between 0 and 1 and back to 0 again. And we basically wanted to say if x equals 0, then set the sustain to 0 and stop the wheel. but it never quite hits 0 because it's not calculated on every single number. It's calculated per frame, so the frame may be past that number. So instead, we are just looking for values of less than 0.1. So that means that you're very unlikely to get a number here coming out that's exactly 6. It'll definitely be smaller than 6.1. So it might be 0.06, it might be 0.09, it might be 0.02, but it'll definitely be below 6.1 or below 8.1 or below 2.1, right? So all we need to do is slice off. We could probably round down, but there's another function that, I mean, these are all functions of the math chop. So go ahead and add a math chop to this math. And so far, we've only ever used math for ranging. You know, we do to set an input range to an output range. But in this case, we are going to want to do, what is it called? Where does it? It's math chop to slice. Oh, floor mode in the integer here. So integer, it can do either ceiling, which would round it always up. So if it was greater than 6.0, if it was 6.01 or 6.1, it would always be 7. We don't want that. We could round it, and that would probably work, but all we really need to do is just slice it off, which is the opposite of ceiling, which is floor. So 6 with a floor, 6.06 equals 6. Also 6.7 would equal 6. But in this case, it's always going to be very close to 6 anyway, or very close to that integer. This way we get the true integer. So let's add a math object for each of these. And now on this one, I want to set this integer to floor. Now that's an 8. And then an integer to this. Sorry, a math. And integer floor. Okay. Put them slightly below where this connection line is. You want to be able to see that connection line from wheel post going into the wheel. You don't want to actually come from the math object into the wheel position, because then it would just be the wheel, instead of smoothly turning, would just go straight to each number in a choppy way. So we're going to leave those connections, but we're going to use the outputs of these new math functions as. Oh, and you know what? I forgot about this. We don't actually need 3 of these. We can have multiple channels. And how do I do that? Can I just put it straight in there? I can. Look at that. All right. So now we don't really need 3 of these. We just need the 1. So now we have this object with 3 channels. This math object with 3 channels. All I did there was put the input of each chop into this math object, which can take multiple inputs. Okay? Cool. So that's ready to send to our logic operator. Right. But I don't want to. We want to be able to test these different logic operations, and if we have to spin the wheel 100 times to win once, or even more maybe, then we'll never get to test these things fully. So we want to actually have an override system that just sends winning conditions similar to what would be here into our logic ChopExec that we're about to build. So we need to create a system to set our own values so we can test this. So just create a constant. Remember, so constant chops are ways for you to set your own values. Null chops will only pass a value that's input into them. pass that on. And then math is used for these different math operations like rounding or flooring or ranging is the most common way we use it. But you can also use it for addition and multiplication and all kinds of other stuff. But in this case, we want a constant chop. And we want, by default, it gives you one channel called chan1. We want to add different channels. So let's go ahead and add a chan2 here and a chan3. All right, so now we have 3 channels, and we can test these out. We can put them whatever we want, although the sliders only go between the sliders only go between 0 and 1, but that you can just type whatever number you want. So actually, if I type a 10, a 9 in here, I think it does this. No, it doesn't. All right, but you can type whatever you want. So an 8, an 8, 8, right? Cool. All right. So now we have that, and now we can make a ChopExec and attach it to this. So it's a DAT. It's a ChopExec or ChopExecute Dat. So this is where I would talk about what kind of conditions we want to test for. Obviously, the most common condition you're going to want to test for is, are all 3 wheels the same? And that's easy enough. And then we may want to, if we're dealing with numbers, other conditions we might want to test for that are significant are maybe like a sequential thing, like 1, 2, 3, ascending, or a descending condition, 3, 2, 1, right? And then we also want like a special case for all 7s, say. So those are like 4 win conditions: is all the same, ascending, 3 wheel condition, 3 win conditions, all the same, ascending, descending, no 4, I can't count, all the same, ascending, descending, and all 7s. Those are our 4 win conditions, and then anything else will be a losing condition, right? So how do we do this? Well, we want this to be, we need to come up with a trigger system for controlling this. And let's see, where are my parameters on my notes here? Let's see, we're going to add spin complete constant. All right, well, let's do that. For now, let's add another constant, and this is going to be what will control the, so this is a constant chop, and call this constant spin complete. Okay? So what we'll do is we'll add some code on when wheel 3 kicks into its final, position. It'll flip this spin complete from 1 to 0, or from 0 to 1, and then when you spin it, it'll flip it back to 0 again. All right, so then we're going to want to add code in this ChopExec to, let's go ahead and name this. Let's call this simple payout system. Okay. All right. We're going to start, we're not going to actually, we haven't built a bank yet. That'll probably be next week. But for now, we're going to start with some, just some messages that we'll send to the text window that tell you what, that'll declare whether you win or not. Now we're going to add code to the, all on to off, off to on. So when this flips from off to on, then it will do it. Let's make some definitions first. We're going to define some channels by we're going to define some channels up here so that we don't have to type them out every single time. So basically, we're looking at wheel 1, wheel 2, and wheel 3, and we have to tell it what the heck wheel 1, wheel 2, and wheel 3 is. So we're going to say wheel 1 equals op, open parenthesis, single quote. Did we never named this. It's just called constant 1. So this constant 1 right here, let's name this logic test. Okay? This is that constant that we added to test our logic, right? Logic test. So over here we say wheel 1 equals op logic test in single quotes, close parenthesis, dot. Nope, it's not a dot, it's a channel. And we're going to say this is channel 0. And then this one, because that will be this first channel, because it starts counting from 0. So this is 0, this is 1, this is 2. Right? See, value 0. All right, equals op logic test channel 1 equals op logic test. Oops, forgot my single quote. Channel 2. Okay, so now instead of having to write out op logic test 0, op logic test 1, op logic test 2, we can just write wheel 1, wheel 2, wheel 3. And that will be way easier. All right, so now here, tab over, we're going to add an if statement. If, and the first thing we'll test for is to see if it's a jackpot. So we're going to say if wheel 1 equals, and we could say we're going to do all 7s, right? So we could say equals 7, and so you could say and wheel 2 equals 7, and wheel 3 equals 7. That's one way to do it, but it's not very elegant. There's a better way. All you have to do is add more equals signs. And why am I doing 2 equals? Because this is an actual logic operator. When you're saying this variable equals 7, you actually do 2 equals. Otherwise, when you have a single equals like this, you're declaring that it equals instead of asking whether it equals, right? So logic operators will send a 0 or a 1 depending on what the question you're asking is true or false. So if the wheel 1 is equal to 7, this will send a 1. Otherwise, it'll send a 0. So if wheel 1 equals 7 equals wheel 2. Actually, we just need to ask if they're all the same and they equal 7. So wheel 1 equals wheel 2 equals wheel 3 equals 7 would be the most elegant way to ask if they're all 7. Because if they all equal themselves and they equal 7, then it'll work. So you put the condition, you set up the question, you put a colon, then you tab over and you tell it what you want it to do. So we're going to print jackpot. Okay. Now we need else conditions. So what to do if that's not true? If I just put else, then any other thing it would do. But instead, we want to do an else if. So we're going to run through our first condition. If they're all 7s, then print jackpot. Then the second condition we're going to look at is if they're all the same. And in some, if you've ever programmed before, you may have used else ifs. That doesn't work in Python. They just what do they call it? They contract that to elif, which is just else if. It's just they decided to make it confusing, I guess. I don't know. Actually, let's put a return here so it makes things a little bit clearer. So elif. Now we're going to say we're just going to ask if they're all the same. Wheel 1 equals wheel 2 equals wheel 3 colon print matching condition. Whoops, forgot my close parenthesis. There we go. Okay. Now we're going to add our next condition with another elif. Why can't I zoom in? There we go. All right, elif. All right, so our next matching condition is an ascending condition. And how could I ask the thing if 1 is 2, 1 is 3, and 1 is 4? There'd be a whole bunch of different combinations I'd have to say. I'd say, is wheel 1 0, wheel 2 1, and wheel 3 2? Is wheel 1 1, wheel 2 2, wheel 3 3? Is wheel 1 2? Is wheel 2 3? Is wheel 4 or wheel 3 4? That would take me forever to do all of those permutations. There's an easier way. All I have to do is do some simple math to bring wheel 1 up 1, wheel 3 down 1, and then ask them if they're all the same. Hello. All right, so we have wheel 1 here, wheel 2 here, and then wheel 3 here. All you have to do is bring wheel 3 down 1, bring wheel 1 up 1, and now all 3 are the same, right? Okay. So let's do that. All you have to do is say wheel 1 plus 1 equals, and let's put this in parentheses. I'm not sure whether we need it, but that's the way I have it in my notes. Wheel 1 plus 1 equals wheel 2 equals in parentheses wheel 3 minus 1. Okay? Colon. Don't forget your colon. And tab over and print, open parenthesis, and put in single quote. Ascending. Actually, that would be a descending condition. Right? No. Yes, no, it would be an ascending. A-S-C-E-N-D-I-N-G. Ascending condition. Okay. New line, back up. All right, one more elif. Elif, wheel, 1, and this time for the descending, we're going to subtract 1 from the first wheel and add 1 to the third wheel. So wheel 1 minus 1 equals wheel 2 equals in parentheses. Oops, I forgot to close my parentheses here. Equals wheel 3 plus 1 colon print descending condition. All right, that should do it. Oh wait, one more thing. And then we just need an else. Else. So if it's none of those, then you didn't win. And so say else colon tab over print losing condition. All right, that's everything. So let's try this out. First, we need to specify what chop we're looking at. And we are going to be looking at the spin complete chop, because that's what's going to trigger this, right? Spin complete. Or I can drag this here, and that works as well, as long as this is not in viewer active. You do viewer active, it's not going to work. And if you try to drag it into the parameters here, these are not going to work. You don't want to do that. All right, so there we go. Those have the association now. And but it's not going to work unless we turn off to on, and turn off value change because we're not using it. Okay, so is this my text window? No. Where's my text window? I can never remember where it is. Well, I know if I go up here and I say view, no, what is it? Dialogues there. Dialogues, text port. There it is. There's my text window. All right. So right now they're all set to my logic test. These are all set to 8 right now. So go make sure they're all set to all the same, but not 7s. Go away, iTunes. I don't care. I don't want to update. I don't care. Leave me alone. All right. So now, again, you can change these by hitting parameters, going into these and typing in numbers here. So let's change these to 6s. Okay, now over here on our spin complete, go ahead and drag this to 1 and then drag it back to 0. Syntax error, end of line. I must have messed something up. It says line 21 has got a problem. Print ascending. Oh, I can see it. I forgot a single quote. See, there's no single quote there. So let's fix that. And ascending condition, single quote. All right, let's try that again. So let's clear this. All right, so all I have to do to activate this is to drag this to 1. And when I do that, it'll activate this ChopExec. That's doing our simple payout. What now? It says compile error, line 24, descending condition. I must have forgot it again. Oh my gosh, I'm so bad. All right. single quote, close parenthesis. I don't know what I'm doing. All right, let me just check over. All right, I think the rest of them are done. Let's try this one last time. Drag over. What now? Oh, I misspelled the word wheel. This is not going very well. Line 14. At least I'm showing you guys how you can debug this stuff. So I'm looking at line 14. Line 14. If wheel 1 equals wheel 2 equals weeple 3. All right, fix that. Clear it again. Let's try it one more time. Matching condition. It worked this time. All right, now let's change these numbers. So let's just make it a lose condition. So change that to 2. All right, now go back to your spin complete. Drag that back to 0 and back up, and it says lose condition. Drag it back down to 0. Change your logic test. Let's do 2, 3, 4. 2, 3, 4. Spin complete. Go back down to 0. Go up. Ascending condition. Let's test a descending condition. 4, 3, 2. Spin complete. And descending condition. All right, and now for the jackpot. 7, 7, 7. Go back down to 0 and go up. Jackpot! It works. Okay, cool. So now we need to have that spin complete. Yeah, we need to make sure that the spin complete goes back to 0 and then goes to 1 at the end of that. So let's do that. Okay, so in here in spinner 1, when this comes in, we know that this activates first when the button comes in. And that's when it starts this going, right? So we can here, in this ChopExec, we need to get the reference to something outside of this, which will be an absolute reference. So we have to point to the object, which is op single quote, and then it will be /project1 / what's it called? Let me go back out real quick. So we can't just name it because we can't use a relative reference because it's not inside the location where we currently are. It's called spin complete. So this is /project1 / spin complete. So in spinner 1, in ChopExec1, op open parentheses single quote /project1 / ooh, I got to plug in / spin complete single quote close parenthesis .par .value 0 equals 0. Whoops, equals 0. That'll set that to 0 when you first hit the button. And let's test that right now. So on the spin complete, right now I have a value greater than 0. Let's go ahead and make sure you have a value that's greater than 0. Now if I click the button, that should go down to 0. And it does. Great. Now we need to, in spinner 3, when this is done, then set that back down to 1. And that happens when this ChopExec stops everything, right? So we have this, and that's when that goes to the wheel stop, right? So here we can add another reference. And this is in spinner 3, right? We don't need to do anything to spinner 2 because we only care about when we start this and when it ends. And so when it ends is when the last wheel stops. And this is the code that triggers when the last wheel stops, so we might as well add our code here. So again, op, open parentheses, single quote, / project 1 / spin complete. Dot par, oh sorry, for single quote, close parenthesis, dot par, dot value 0 equals 1, and that will set that to 1. So let's go ahead and test that out. So this is still giving me some weird bugs where it doesn't always spin these wheels. I have to hit it 3 times. I have to figure out what's causing that. But when I hit it 3 times, it seems to work. And you can see, whoops, you can see that this had gotten set to 0 when I clicked it, and now when it's done, it goes to 1. And that's not working again. There it goes. Okay. There's definitely something going on there I gotta fix. Great. And you can see because we had 777 matched here, we got a jackpot 3 times in a row.
Come on. Come on.
Okay. So now if we wanted to actually hook it up to this what's coming out of these wheels, instead of our logic test, we just need to hook it up to this math. So here in our simple payout system, instead of looking at op logic test 0, 1, and 2, we're going to look at op math 1. Math 1, channel 0, math 1, channel 1, and math 1, channel 2. And now it should, although I still have that bug, I'm going to go ahead and stop here for a second and figure out what that bug is. But regardless, if I click it a couple times, it works the way it should work. And those wheels will spin. And they'll stop. And when they stop, it'll tell me losing condition, right? So let's click it again. Yeah, I don't know what's up with that. What up with that? 7, 3, 1, losing condition. And I could do this all day and not win. That's Vegas. 6. Nope. Let's try it. See if I can get 1. No. 1 winning condition would be great. 9, 2, 9, 8. No. All right. Whatever. My battery's going to die before I win. And I keep having to hit this more than once, so I'll try to figure out what that is and I'll edit together these videos. For the rest, oh, if I only got a 7, I would have had a winning condition there. Alright, so I looked over the patch for a while, and I can't figure out where that error is, and I can't reproduce it when I'm not screen recording. So I'm guessing that the screen recording, plus I had that camera still active to turn on my webcam, that both of those are bringing my frame rate down. See, right now when I'm screen recording, you can see my frame rate is only like 15 frames a second. That's causing the issue, right? And if I go into, I'm betting that if I go into, even while I'm screen recording, if I go into performance mode, this won't be an issue. So let's try that out. See, it works fine because it's working in performance mode. It optimizes everything, and it's still running even while I'm screen recording at probably around 60 frames a second, and that bug doesn't happen, hopefully. Yeah, see, it's working. All right. So yeah, that seemed to be a bug based on performance, and I'll see if I can't figure out a workaround to make it work even when there's a low performance situation. But it seems to be okay. So there's only one more thing I want to do for this lesson, and that's to go ahead and put in the complex payout code. So let's do that. So this is our simple payout system. Let's duplicate this. Copy and paste it, and name this one complex payout. Okay, so on this, there's just a few things we want to add. We're going to leave this jackpot. We're also going to start adding in, let's add an op called a constant called award to hold our, let's see, yeah, constant. And call this one award. And this is where we're going to put in how much money you win. Award. Okay? So we're going to leave this condition in the everything equals 7, and that's our jackpot. We're going to leave the print messages in for now. And then we're going to put a, actually let's go ahead and might as well define it up at the top so we don't have to keep typing it out. Award equals op award dot par dot value 0. So now we can just set the award by just saying award. We don't have to type it out every single time. Okay, so we're going to print jackpot, and then we're going to set award equals, what are we going to make? 500. We'll say $500 for hitting the jackpot. Okay, now we have some new conditions here. So let's see here. Let's get rid of this. Let's just delete this for now. And grab this, because we're going to have a couple different awards based on what the number is. And this will equate to what the symbol, like the cherry or the lemon symbol is when we switch over. So just paste that back in. So now we have this jackpot twice. And we're going to call this award, we're going to call this level 10 payout. And this is not an if, this is an elif. an else if, elif, right? All right, so this is wheel 1 equals wheel 2 equals wheel 3 equals 0. So if they're all 0, then we get the level 10 payout, and the award is 200. Okay, now let's do this elif again. Let's grab this code and paste it in. Make sure you go back to the same tab that the if statement was on. And then we go wheel 1 equals wheel 2 equals wheel 3 equals 9. And this is level 9 payout. And this is 100. This is all based on like an old fruit machine. I can't remember off the top of my head which fruit symbol 0 is and which fruit symbol 9 is. I know that I believe 7s are the lucky 7 jackpot symbol. All right. The next one is 990, and that's a level 8. So we can't use this equals wheel 1 equals 1, wheel 1 equals wheel 2 equals wheel 3 equals 9. Instead, we're going to say elif wheel 1 equals, we're just going to specify them and then put ands in between. 9. Actually, we can do it this way. Wheel 1 equals wheel 2, because these two are both going to be 9s, equals 9. And wheel 3 equals 0. Colon. Tab, print, level 8 payout. Award equals 70. Not minus, equals. There we go. Okay, and the next one is, so that was 990. The next one is they're all 8s. So that's the same as this one. Let's grab this. Copy that. So that's the wheel 1 equals wheel 2 equals wheel 3 equals 8. And that's going to be a level 7 payout. And the award is 50. Okay, the next one is an 880. So that's the same as this here, the level 8 payout code. Paste that in, and then change this from 9 to 8. So 8, these are both 8, and wheel 3 equals 0, and this is level 6 payout, and the award is 40. Okay, and the next is they all equal 6. So that's the same as this code. And you just change this from 8 to 6. And this is a level 5 payout, and the award is 30. Okay, then a 660 is the next one. So grab this code. Actually, I don't have to type it, just paste it. There we go. And change this to 6. And this is a level 4 payout. We're almost there. And this is level. Last one was 30. This one's 20. Okay. Next is they all equal the same. So, and any of these that aren't one of the special cases, then they all equal the same. We can grab this code, put it here, and we can just get rid of this last thing. Actually, just say, wait, what did I do? Oh, whoops, I did the wrong one. I want the one where they're all the same. Shouldn't have an and. There we go, this one here. The level 5 payout. Grabbing this code. Okay. And we can get rid of this equals 6 and just say wheel 1, wheel 2, and wheel 3 all equal each other. This will be the level 3 payout, and the award is 15. And I believe there's more than one level 3 payout. Let's see. In my notes. Yeah, there's another. Okay, so they all are the same. That's a level 3 payout. We have 113 is also a payout. 119 is also a level 3 payout. Okay, so let's do that. So that's this code. So this is 1. So wheel 1 equals 1, wheel 2 equals 1, and wheel 3 equals. Let's see here. Wheel 3 equals 3. 113. That's also a level 3 payout. And that also pays 15. Okay. Then 119 also, so just paste this code back in again and change this to 1 and this one to 9. That's also a level 3 payout, and it equals 15. Okay. And 119. Here's a big complex one. Okay. Wheel 1 equals wheel 2, and wheel 2 equals 1. Oh, okay, so, or wheel 1 equals wheel 3, and wheel 3 equals 1, or wheel 2, wait. So any 2 equal 1 is a level 1 payout. Oh, wait, where's the level 2 payout? Oh, 119 is a level 2 payout, actually. All right, so this is a level 2 payout. There we go. All right, there's one more one that's kind of weird, and it's basically any 2, which I believe are like the bars. If any 2 bars equal 1, or any 2 wheels equal 1, then that's a level 1 payout. And because of that, we have to do like 3 different conditions, because either 1 and 2, or 2 and 3, or 1 and 3 are the 2 different ones. So this one's a little bit strange, but here we go. Elif wheel 1 equals wheel 2 equals 1, or wheel 1 equals wheel 3 equals 1, or let's see. Yeah, 1 and 3, or wheel 2 equals wheel 3, whoops, 3 equals 1. Yeah. That should work. We'll see. We'll test it here in a second. Colon. Print. Level 1 payout. Award equals 3. Oh, in this level 2 payout, this award should not be 15, it should be 10. Okay. Whew! Now we just have one thing left, and that's the elif, or just else actually. Else print lose condition. And let's go ahead, whoops, don't forget that. And then let's go ahead and set that award equals 0. All right. This should work, let's hope. Okay, so this is also going to look at the same, it's looking at the same spin complete. Let's, up here, let's go ahead and set this to logic test instead of math so that we can test it without having to spin the wheel, which we'll always lose that way. Okay. Oh, whoops, sorry, this undo. There we go. Oh no, it undid all of them. I just didn't want it to change the award. Ugh. Logic test. Logic test. Logic test. Okay, that's the only 3 things that we need to do. All right, so right now, let's see. If I open the text port, there it is. We're currently, and my logic test right now is set to 777. Oh, let's here on the simple payout system. Let's disable this for now. All right, so it's going to disable the simple payout system, so that way we're only getting messages from the complex payout system. So I'm going to clear this, and right now our logic test is set to 777, and here is our spin complete. And if I drag this back to 0 and then go up 1, it says jackpot. But why did my award not work? Maybe that doesn't work. Oh wait, did we turn? Maybe I didn't turn it on. Should be. Parameters? No, it's on. Value 0. It's definitely called value 0. All right, well, maybe I can't do it that way. Let's see here. Can I do it that way? If I have to do it the long way. Yep. Well, apparently this shortcut doesn't work. Darn it. Oh, all right. Well, we could, maybe it'll work this way. Let's see. Can I do it this? Let's see here. Award dot par dot value 0. That will save a few keystrokes. Nope, doesn't like that. It says script errors unbound local variable referenced beyond before assignment. Oh, okay, whatever. So grab where it says, so we want to make op award dot par dot value 0, and we just need to paste over every place where we said award, because apparently that doesn't work. So let's do that real quick. Not want to take too long. Five, 4, 3, 2, 1, 0. All right, one more time. So let's change this now to a losing condition. And then grab our spin complete. And you can say it says lose condition 0. All right, let's test some of these out. Let's see. We want a, so we did 777. Let's try a 000. That should be our level 10 payout. Level 10 payout, 200. Cool. All right. Let me cut down to the middle somewhere. Let's try the weird level 1 payout, which could be 1 something 1 something 1 or something 1 right? So here we go. Logic test. So let's have it be a 011, which should be a level 1 payout. Level 1 payout. It works. All right. Let's try a different level 1 payout. Let's try a 101. Yep. All right. Let's try a level 6 payout, which should be an 880. Level 6 payout. All right, I think this is working. All right, so if I wanted to hook this up to the actual system, all I need to do is up here at the top. This wasn't working. I'm going to go ahead and pull that out. Sorry about that. Change this from logic test to, I believe, it's called math 1. Math 1. All right, now if it doesn't crash on me, this should work. Yeah, there we go. Okay. They're spinning. And I got a 251 and it says lose condition. All right. Five, 8, 9, lose condition. All right, that's it for today. So I'll see you at class on Wednesday, and we'll go over any problems you had on this lesson, and we'll continue on from there. We have to build a banking system. We have to build a system to display how much money that we have on the screen, and then probably the following week we'll start with we'll finish it off with some coins falling and stuff like that, and then we'll move on from there. All right, so stay healthy, stay safe, and I'll see you on Wednesday.